my name is Goran Perica. I'm the Applications Engineering Section Leader for Power Products at Linear Technology. Today I'm going to talk about a great new product, the LTC3788 PolyPhase Boost Converter. This is a product aimed at the most demanding automotive, industrial, medical, and commercial boost converter applications, where high power, high efficiency, and low EMI are crucial features. Some application examples would be high-end automotive audio systems, valve actuators, motor drives, and power over Ethernet backup systems. First, let's take a look at an example of boost converter and review some of boost converter basics. In this example, we are boosting 6-volt input to 12-volt at 10 amps output. To meet the 10 amp output requirement, the input current, power switch current, and output rectifier current will have a peak over 20 amps. Our boost converter example has only 1.9 amps of RMS input ripple current, which is easy to filter with a small input cap. However, in this example, the output capacitor has to support over 10 amps of RMS ripple current. The required output capacitor with 10 amps RMS ripple current rating will be rather large. To achieve higher performance and reduce the electrical stresses, we can use polyphase converter shown in this block diagram. In this converter, each phase handles only 1/2 of the current compared to single-phase converter. The two phases are running 180 degrees out of phase, which results in lower input and output ripple currents. Compared to single-phase converter, our two-phase LTC3788 circuit has virtually no input ripple current. Also, the output ripple current has gone down from over 10 amps RMS to 2 amps RMS, a 5-fold reduction. This means that a 5 times smaller output capacitor can be used. The next graph illustrates what is happening with the output ripple current as we change the input voltage and duty cycle. A two-phase boost converter has lowest ripple current at 50% duty cycle. Therefore, two-phase converter is ideal for boosting 6 volts to 12 volts or for boosting 12 volts to 24 volt output. However, to boost 12 volt to 48 volts, we would need 75% duty cycle and ripple currents go back up. In order to bring the ripple currents down again, we would need to use 4-phase converter. Also, polyphase boost converters can lower the EMI. The effective ripple frequency is a multiple of switching frequency and number of phases. A 4-phase converter running at 500 kHz has effective ripple frequency of 2 MHz, which is much easier to filter than 500 kHz. As we can see in this typical application, the LTC3788 polyphase boost converter is simple, efficient, and small. Only a handful of external components are required to achieve excellent performance. Some of the great features of LTC3788 are listed on this slide. The LTC3788 is suitable for demanding automotive, industrial, medical, and commercial applications in the range from 50 watts to 500 watts. The polyphase operation allows the use of small input and output caps. Also, the EMI is lower and easier to filter thanks to polyphase operation. The LTC3788 can support input voltages from 2.5 volts to 38 volts with outputs up to 60 volts and all that with 1% tolerance. The synchronous operation of LTC3788 results in efficiencies over 97% in boost operation and over 99% in wire mode when input is higher than the programmed output voltage. The unique wire mode of LTC3788 is possible thanks to the built-in charge pump. The benefits of LTC3788 synchronous rectification are easy to see on a thermal image comparing MOSFET to Schottky diode. The Schottky diode operating temperature of 107 degrees Celsius is clearly troublesome. The MOSFET running at 80 degrees C temperature is much easier to handle and may save the costs of heatsink or a fan. The reduction in power dissipation over non-synchronous rectification is over tenfold. In conclusion, the LTC3788 is a state-of-the-art synchronous polyphase controller that pushes the envelope of power density and efficiency to new levels. This translates directly into improved performance of your system. For additional information, please visit linear.com. Thank you for watching.